All right, everyone. Hello, we're going to be doing section 2.4. So in section 2.3, we learned more about linear equations. And for section 2.4, we're going to do applications of these linear equations. So we have four objectives. Our first objective being that we want to learn the 6 steps for solving applied problems. Number 2 being solve problems involving unknown numbers. Number 3 being solve problems involving sums of quantities. And number 4, solving problems involving consecutive integers. So with our objective 1, we want to learn the 6 steps for solving applied problems. So in section 2.3, we learned about the 4 steps for solving a linear equation. And now when we have applied problems, we're going to have a separate 6 steps. So these are going to be a little bit different. Our first step being that we just want to read the problem. We can read it as many times as we would like, several times, how many times you need. You want to think about what information is given and what needs to be found. Step 2, we want to assign a variable to represent the unknown value. You can use a sketch, diagram, table, whatever you would like or whatever you would need. And you want to express any other unknown values in terms of that same variable. So we're just using one variable in this case, and we're just using any other values as kind of manipulations of our one variable. Step 3, we want to write an equation using the variable expressions. Step 4, we solve the equation. Step 5, we state the answer. We label it appropriately. We think of it, does it seem reasonable? And then 6, we want to check the answer in words of the original problem. So we check our answer with whatever we were originally given. So using these 6 steps, we can go ahead and start solving our applied problems. So objective 2, we want to solve problems involving unknown numbers. So these are just going to be solving problems with unknown variables. So we want to find the value of the unknown number. The product of 5 and a number decreased by 3 is 75. So let's read it again for step 1. The product of 5 and a number decreased by 3 is 75. So we've read the number here. What we want to find is whatever this number is that's being decreased by 3, because we know when we multiply this by 5, we're going to get a value of 75. So let's start with step 2. Step 2, we want to state our unknown, and we're going to let x be this unknown number. It's pretty standard whenever you have an unknown number that we typically choose x, but you could choose whatever letter you would like. So we've identified our variable. We've assigned it a letter. So now for step 3, we want to write our equation. So our statement here, which we're just going to turn into one line so we can kind of mark it up a little bit. So our statement here, the product of 5 and this number decreased by 3. So let's start with this number decreased by 3. So a number decreased by 3, this is going to be x minus 3. This is our expression x minus 3. Then with the product of 5, we're looking at multiplying 5 and x minus 3, minus 3. And then is 75, this is, equal to. So when we write our equation, keeping this in mind, we're multiplying 5 and x minus 3 to equal 75. So this is going to give us 5 times x minus 3 is equal to 75. So there we have it. There's our equation. And now in step 4, we want to solve. So just real quick, step 2, we assigned a letter to unknown. Step 3, we wrote the equation. Step 4, we're solving. And remember that step 1 was to read. So step 4, we're solving this equation now. And our first step in solving is we can use our distributive property to distribute a 5. So it's going to give us 5x minus 5 times 3 is equal to 75. And now we solve with all the same methods and properties that we've learned so far. So 5 times x is going to be 5x, 5 times 3 is 15, and this is equal to 75. We're solving for x in this case, so we want to use our addition and multiplication properties of equality. So let's start with isolating our x term on one side. So let's add 15 to both sides in order to isolate it. So we'll get 15x, 5x minus 15 plus 15 is equal to 75 plus 15. And now this is going to give us 5x is equal to 90, 75 plus 15. And now we have our x terms isolated to one side, we have our constants isolated to one side, and now we just need to divide each side by 5 in order to solve for x. So let's do this in red. Divide each side by 5. This is going to give us 1 times x is equal to 90 divided by 5. Now, 90 can be written as 18 times 5 divided by 5. And now we have a 5 in our numerator and our denominator. So we get now that x is equal to 18. So this is our solution here. So this is technically step 5. And we have most definitely run out of room. So step 5 was our solution. So we have x is 18, where x was our unknown number. But as always, we want to check and make sure that this is our solution. So our step 6 is plugging in 18 for x into our original equation. So into original equation. And the original equation that we're using is the one that we found in step 3. So in step 3, we stated 5 times x minus 3 is equal to 75, where now x is 18. So 18 minus 3 is going to be 15. 5 times 15 is in fact 75. So 75 is equal to 75. And this means that in our step 5 here, x equals 18 was our unknown number. Our unknown number was 18. So these are kind of like the basic, or this is a basic problem that we use to separate out our 6 steps that we had in order to solve for this unknown. So now we can go ahead and do a slightly harder problem. So in objective 3, we want to solve problems involving sums of quantities. So as a tip here, we have that in general to solve problems involving sums of quantities, we choose a variable to represent one of the unknowns, and then we represent the other quantity in terms of the same variable. So this is just reiterating the fact that we're going to use the same variable, and we're just going to have a manipulation of that variable as our second unknown quantity. So saying that, for example 2, we have that at the 2014 Winter Olympics in Sochi, Russia, the United States won 13 more medals than France. The two countries won a total of 43 medals. How many medals did each country win? So step one, we read it. Let's just read it one more time. At the 2014 Winter Olympics in Sochi, Russia, the United States won 13 more medals than France. The two countries won a total of 43 medals. How many medals did each country win? So step two, we assign our variables. We assign our quantities. So we've read, that was step one. Step two, we're assigning. So let's say that X is the number of medals that France won. So X is the number of medals that France won, and we know that oh my God, I cannot speak just now. The United States won 13 more medals than France. So we take whatever number that France had and we're adding 13. Since we don't know what the number of medals that France won, we're just adding 13 to X. So we're going to say that X plus 13 is the number of medals the United States won. So we have our two unknowns. We have the number of medals that France won, and we have the number of medals that the US won. So now we want to write our equation. So with step three, we write our equation, and we know that the sum of these two unknowns is going to be equal to 43. So all we need to do is add our unknowns. So this is going to be X plus, well, actually, let's write it out in words first, and then we can write out our actual equation. So we know that the total, or restart, we know that the number of medals that France won plus, so our operator plus, because we're working with the sum, plus the number of medals the US won. And this is equal to our total, which was 43. Or our total medals. So we'll say total medals. And now we can combine our terms here. So our number of medals that France won, we represent as X. Our number of medals the US won, we represent as X plus 13. And our total medals was 43. So this gives us our equation of X plus 13 is equal to 43. So this is our equation. And for step 4, we want to solve. So let's do that. X plus 13, which is in parentheses, is in its simplest form. So there's really no point in having parentheses. So we can just write this as X plus 13, which is equal to 43. Combining our like terms, we get 2x plus 13 is equal to 43. And now we've combined our like terms. So now we want to isolate x on the left-hand side. So let's subtract 13 from both sides. So we'll get 2x plus 13 minus 13 is equal to 43 minus 13. And our positive 13 minus 13 is going to be 0, which will just give us 2x is equal to 43 minus 13, which will give us 30. And now we want to solve for x. So we need to divide each side by 2. And when we divide 2x by 2, that's just going to leave us with x. And 30 divided by 2 is 15. So we have x is equal to 15. Now our step 5, we just want to state our solution. So we have x is equal to 15, and this is the number of medals France 1. And x plus 13, which will now be 15 plus 13, is 28. And this is the number of medals the US won. So we use the expressions that we know for our unknowns. So step 2, we use our x and x plus 13 to state our solutions. So we had x is equal to 15 and x plus 13 is going to be 15 plus 13, which was 28. Then finally in our step 6, we just want to check and make sure that these are correct. So we will replace x with 15 and x plus 13 with 28. And our original equation here, which was x plus 13 is equal to 43. Ooh, we're about to run out of room again. So we had x plus 13 equal to 43. We know that x is 15. X plus 13 is 28. Is equal to 43. And when we add 15 to 28, we do get 43 is equal to 43. So our solution, which was technically in step 5, x equals 15 and x plus 13 was 28. So our final solution here is that France won 15 medals and the US won 28. And that would be our final answer there. And moving on, which we had run out of room, with our problem solving hint. So we have another hint here. Is that the problem in example 2, which we just did, could also be solved by letting x represent the number of medals that the United States won. Then x minus 13 would represent the number of medals that France won. An equation would be different. So this would end up being 43 is equal to x plus x minus 13. So this is another way you could have written that example or that problem. The solution of this equation is 28, which tells us the number of the US medals. The number of French medals would be 28 minus 13, which is 15. So we get that the answers are the same, but the setup can be different. But either way, you should end up getting the same answer, whichever setup you go with. Another hint would be that sometimes we must find 3 unknown quantities. And when 3 unknown quantities are compared in pairs, we let the variable represent the unknown found in both pairs. This is just to say that if now we have 3 unknown quantities, we still want to use the same variable and just express them differently or use manipulations of that one variable. So let's do a problem with 3 unknowns.